Welcome to another video by the Security Buddy. In this video, we will discuss what the adjusted R-square score is and how we can calculate the adjusted R-square score. In our previous video, we discussed what the R-square score is and how to calculate the R-square score. We also discussed that we often expect a high R-square score that is closer to 1. But a higher R-square score does not always mean that the model performs better, and a lower R-square score does not always mean the model performs worse. For example, if we increase the number of predictor variables in a linear regression model, the R-square score of the model increases. If we keep increasing the number of predictor variables, the R-square score also increases. And that happens even though the newly added predictor variables do not improve the performance of the model. For example, the newly added predictor variables may make the model overfitted. So, to address that problem, we use adjusted R-square score. If we keep adding predictor variables in a linear regression model, the R-square score increases, but the adjusted R-square score decreases after a certain point. In other words, if we add a new predictor variable that does not improve the performance of the model, the adjusted R-square score will decrease, even though the R-square score increases. So, how do we calculate the adjusted R-square score? Let's say x is an independent variable and y is a dependent variable. In our previous video, we discussed that if there are endpoints and for a specific capital X, say xi, the observed value of y is yi and the calculated or fitted value of y is yi hat, then R-square score is calculated as follows. R square is equal to 1 minus SSE by TSS. Here, SSE is the sum of squared error and it is calculated as summation from I is equal to 1 to n yi minus yi hat whole square. And TSS is the total sum of squares and it is calculated as summation from I is equal to 1 to n yi minus y bar whole square, where y bar is equal to summation from I is equal to 1 to n yi by n. In other words, if we take the difference between the observed values and the calculated values of y, square them and sum them up, we get the sum of squared errors or SSE. And if we take the difference between the observed values and the mean value of y, square them and sum them up, we get the total sum of squares or TSS. Then we divide SSE by TSS and subtract the result from 1 to get the R-square score. In the case of adjusted R-square, it is calculated as follows. Adjusted R-square score is equal to 1 minus SSE by DFE divided by TSS by DFT. Here, DFE is equal to n minus p minus 1, where n is the sample size and p is the number of predictor variables, and DFT is equal to n minus 1, where n is the sample size. So, after some calculation, adjusted R-square score becomes 1 minus SSE into n minus 1 divided by TSS into n minus p minus 1. Now, R square is equal to 1 minus SSE by TSS. So, SSE by TSS is equal to 1 minus R square. Hence, the adjusted R square score becomes 1 minus R square into n minus 1 divided by n minus p minus 1. Adjusted R square is always less than or equal to R square. If adjusted R square is 1, that means the model perfectly predicts the target variable. And if the adjusted R square score is 0, that means the model has no predictive value. I hope this helps. Interested viewers who want to know more, please refer to the playlist Linear Regression or Statistics for Machine Learning, or visit the website of the Security Buddy. The relevant links are provided in the description. You may also want to subscribe to us and get notifications on recent videos.